I'm Arav, and in this video I'm going to show you how I designed, 3D printed and assembled a planetary gearbox for a 775 motor. Inside the gearbox there are many gears. This is called the sun gear and this is called the ring gear. And these three gears are called the planet gears, which is connected to a carrier which is supported by a bearing. To calculate the gear ratio of this gearbox, first note down the number of teeth on the sun gear and the number of teeth on the ring gear. The planet gears would equal the sum of both of this, which is 45 teeth, and the final ratio would be equal to the number of teeth on the planet gears divided by the number of teeth on the sun gear, which is 45 divided by 11, which is approximately 4:1. This means that if the motor rotates 4 times, then the output rotates only once. So the speed is reduced by 4 and the torque is increased by 4 times. To test out this gearbox, I have a motor speed controller here, which is connected to the motor and the gearbox. This is the input and this is the output. So I'll slowly start increasing the speed. I also have a tachometer here which will measure the RPM. So I'll check the RPM on the input and the output. The input is around 560 RPM and on the output it is around 140 RPM. So the ratio would be the division of both of them, which is approximately 4. And this matches the calculation which we had done previously. Now I'll be designing the second version of this gearbox in SolidWorks software. This is the final design of the gearbox, and now I'll show you the cross section of it. So this is the cross section. This is the motor. This is the first stage of the planetary gears. This is the second stage. And this is the output. As you can see, the teeth on the first stage of the gearbox is smaller than the teeth on the second stage. And the module over here is 0.7. And the module of this gear is 1. This is because in the first stage, very less torque will be experienced, but in the second stage, more torque will be experienced, but with less speed. Now I'll assemble all the 3D printed components. I'll also use grease in between the gears so that they move freely. This is the gear ratio for the gearbox. In the first stage it is 4.8:1 and in the second stage it is 4.2:1. So the final ratio is 20:1, which means the torque is multiplied by 20 times. So this is how it runs. To measure the torque, I have a power supply, a motor speed controller, the motor and gearbox, a weighing scale, and a wood piece which is 30 cm long. The place where it broke was here, between the connection between the first stage and the second stage. It broke here because it was only a 5 mm diameter 3D printed shaft. So in the future, I will replace this with a stainless steel shaft. I will also replace all the spur gears to herringbone gears as it can handle more torque.